Hello students, welcome back to the 9th video of this playlist. So in this video we will be solving question number 9 from May 2024 P1 regional paper. So let's see what's the question number 9 is about. So basically the concepts behind question number 9, it's discussed in chapter number 7, chapter number 6, chapter number 6, that is trigonometry, and also chapter number 7, you can say like radians chapter, because you need to deal with radians, like the angles in radians here. So to be more specific, you need to have concepts of trigonometric graphs, the graph of tan theta to be specific. So let's get started with question number 9. So in question number 9 you can see a figure 3, a sketch of the graph of y equals to tan x minus pi over 6 radian. Okay, here they said figure 3 shows a sketch of the curve with equation y equals to tan x minus pi over 6 for 0 x greater than or equal 0 less than or equal 2 pi. Okay, so tan x minus pi over 6, this is the sketch in figure 3, and it shows a line L whose equation is y equals to pi minus x. Okay, so in part A they are asking to state the number of solutions of the equation what tan x minus pi over 6 equals to pi minus x in the interval x greater than or equal 0 less than or equal 2 pi. So number of solutions, look, what's the number of solutions represent? Sorry, what's this equation represent? This equation represents the what points of intersection between the two curves or two what sketches, right? So in that case, the number of solutions, if this the number of solutions is basically the number of points of intersection between the two sketches. So here, since you can see that this sketch is from x greater than or equal 0 radian till 2 pi radian, so that means within that interval how many points of intersection you can see between the curve of tan x minus pi over 6 and the line L. This is the first one, second one, and then third one. So there are 3 points of intersection. That means this equation will have how many solutions? 3 solutions. Okay, it will have what 3 solutions. For part A, number 1, what number of solutions is what 3. Okay, part 2, for part 2 what they have asked here, let's see. We need to state the number of solutions of the equation what tan x minus pi over 6 equals to pi minus x in the interval x greater than or equal 0 less than or equal 100 pi. Okay, so here most of the students what they do mistake here is that they consider the proportionality. What proportionality? Since you can see that from 0 to 2 pi there are three solutions. So from 0 to 100 pi how many periods are there? From 0 to 2 pi there are 1 period. So from 0 to 100 pi there will be 50 periods. So for 50 periods the total number of solutions would be what? 150. No, this process is not correct. Incorrect, because there's a problem here with the straight line. Since it is a straight line L, it's a straight line, as you progress to the right, the positive part, the intersection, this intersection will disappear. How? Let me show you using a figure. Look, if I extend the graph, it goes like this, right? And there will be an asymptote later on. Okay, now you can, are there any any line like the part of line L on the positive part? No. On the positive y-axis? No. It will be just on the what? Negative y-axis. Okay, then it will what? After the asymptote the curve will start again from the asymptote, and only you will have the what? Negative y-axis on the, or you will only have the part of the curve on the negative y-axis. Okay, so that's why the positive, this positive intersection will be only available from within this interval. Okay, in the next intervals you will have only the negative intersection points. Okay, so from 0 to 2 pi, this was the limit. From 0 to 2 pi there are 3 points of intersection, so 3 solutions, and then in the next upcoming intervals there will be what? Only 2, right? So in the first interval there are 3, so how many remaining? We already got, there are total 50 periods, right, from 0 to 100 pi. So out of 50, in one of them this is 3, and in the rest of them it will be 2 solutions, right? Only the negative part. Like what I meant, from 0 to 2 pi, okay, from 0 to 2 pi there are 1, 2 points of intersection. So in the first one, this is how many? In the first 0 to 2 pi radian there will be 3 points of intersection, and in the next 49 periods there will be 2. Okay, 2 in each. So total would be 3 plus 49 times 2, that would give you 110. Okay, so we got that would be what? 101. Okay, next is part 3. For part 3, what they have asked here, we need to state the number of solutions of the equation 10x minus pi over 6 equals to pi plus x. It's now pi plus x from 0 to 2 pi. So pi plus x, how would be the line? Look, pi plus x would go like this, right? It will go like this, isn't it? So if it goes like this, how many points of intersection you can see? Let's mark it out. This is 1, right? This is 1, the first one. This is second one. This is the what? This is the second one, we can see. And then there's nothing, because this is till 0, like 0 to 2 pi, right? So 2 pi is basically this point. Okay, this is till 2 pi. Okay, so we will consider these two, this one and that one. So 2 points of intersection, therefore 2 solutions. Okay, so the answer for part 3 of A, this is 2 solutions. Done. Next, for part B, what they have asked for part B, the line with equation x equals to a shown in figure 3 is the asymptote. Yeah, we know that 10x has tan theta. There are asymptotes, vertical asymptotes in the graph of tan theta. Okay, so asymptote to the curve with the smallest positive x coordinate. With the smallest, that is the first asymptote. State the value of a. In part B, they are asking to state the value of a. So what would be the value of a? Okay, right at first consider the graph, the sketch. Y equals to tan x minus pi over 6, right? So this is basically a transformed graph of tan theta. What type of transformation? X minus pi over 6, a constant pi over 6 has been subtracted within the bracket of the function. That means this is horizontal translation, right? And for horizontal axis, what we know, for horizontal transformation always the opposite thing happens. That means here x minus pi over 6, that means the graph of tan theta will be moved to the positive, towards the positive x-axis by pi over 6 radian. Make sense? So that means all the x coordinates, the y coordinates will remain as it is, but the x coordinates will move towards the positive x-axis by pi over 6 radian. Okay, so at first consider, look, x equals to a, this is the first vertical asymptote. So in the graph of tan theta, the first vertical asymptote happens at x equals to what? Pi over radian, right? 90 degree, tan 90 degrees and undefined. Okay, pi over 2 radian. So if we need to, like in the graph of tan x minus pi over 6, it has to be added with what? Pi over 6, since it is moving to the positive x-axis by pi over 6 radian. So pi over 2 plus pi over 6, that is basically 90 degree plus 30 degree, 120 degree. So 120 degree is basically 120 times pi over 180. So that is basically 2 over 3 pi radians. Okay, so the value of a is what? The value of a, x equals to a is equals to what? 2 over 3 pi radians. Done. Next, for part C, what they have asked in part C. Okay, the line with equation x equals to b, also shown in figure 3. We can see the line x equals to b, the vertical line x equals to b. That is basically the second what? This is basically the second asymptote, vertical asymptote on the curve of tan x minus pi over 6 is the asymptote to the curve with the second smallest, what I said, the second smallest positive x coordinate. That is the second asymptote, vertical asymptote. The line L meets x equals to a at point P, okay, and meets x equals to b at point Q. So the line L is meeting the two asymptotes of the curve at 2 points, point P with x equals to a and point Q with x equals to b. So the question C asks here to find the midpoint of the line segment PQ. We need to find out the midpoint of line segment what? PQ. Okay, so how can we find out the midpoint? So in order to find out the midpoint, we need to know the coordinates of point P and point Q. Okay, so at first consider point P. So point P, already we know the x coordinate of point P, right? The x coordinate of point P is what? At P, x equals to what? 3 pi over 2, right? That is, sorry, 2 over 3 pi, 120 degree, 2 over 3 pi radian, right? So at point P, since at point P line L is intersecting the graph of tan theta, so what would be the y value? We can put, since it is the common point, we can put this x value into the equation of line L, that is pi minus x, right? So pi minus 2 pi over 3, that would give you what? 1 over 3 pi radian. So point P has coordinates what? 2 over 3 pi radian. We could also substitute the x value into the equation of tan theta, but it's like it will be time consuming. Okay, so 1 over 3. So it's better to substitute it in the equation of line L. Since it's a linear equation, you will get the value very fast. Okay, so we got the coordinates of point P, then the coordinates of point Q. At point Q, what would be the x value? Look, point Q is the intersection of the line L with the second vertical asymptote of tan x minus pi over 6 radian, right? So we need to find out the x coordinate. We need to find out the x coordinate of the second asymptote of the graph of tan x minus pi over 6. Okay, so to figure out that, at first consider the asymptotes in the curve of tan theta. The first vertical asymptote happens at x equals to pi over 2, right? We have just dealt with this in the previous question. And the second vertical asymptote happens at x equals to how much? 3 pi over 2 radian. 3 pi over 2 radian. Okay, so 3 pi over 2 radian, it is in the graph of what? Tan theta, tan x. Okay, it's in the curve tan x. So tan x minus pi over 6, this is basically translated graph, right? So how it will get translated? We will add pi over 6 with the what? 3 pi over 2. So what you will get? The x coordinate would be at point B, at point Q, x coordinate would be what? X equals to b equals to 3 pi over 2 plus pi over 6. 270 degree plus 30 degree, that is 300 degree. So 300 times pi over 6, the pi over 180, that would give you 5 over 3 pi radian. Okay, so this is the x coordinate of point Q. Okay, so that is 5 pi over 3 radian. This is the x coordinate. So what would be the y coordinate? That would be pi minus 5 over 3 pi radian. Fine. So what it would be? So 1 minus 5 over 3, that is negative 2 over 3 pi radian. So the x coordinate, sorry, the y coordinate of point Q is negative what? Negative 2 pi over 3 radian. So we got the coordinates of point Q, that is 5 by 3 pi radian and negative 2 over 3 pi radian. Now the midpoint. Midpoint of what? PQ, right? Midpoint of PQ, consider this as M. It's what? The average of the x and x coordinates of PQ, and y coordinate of point M would be what? The average of the y coordinates of the point PQ. So 2 over 3 plus 5 over 3, that is 7 over 3. That means 7 pi over 6. 7 over 3 over 2, that is 7 over 6 pi radian, the x coordinate of midpoint, and the y coordinate would be average of the y coordinates of PQ. That is 1 over 3 minus 2 over 3, that will give you negative 1 over 3 pi radian over 2, that is negative 1 over 6 pi radian. So this is basically the coordinates of the midpoint of PQ, and that's all about part C of question number 9. And that's the end of question number 9 from May 2024 P1 regional paper.